Welcome back to the deep dive. Today we're taking a look at something that sounds maybe a bit niche, the infrared light angle sensor market. But trust me, it's actually, well, it's kind of an invisible backbone for a lot of the tech around us. Okay, let's unpack this. Our mission, as always, is to dig into the numbers, the dynamics, the future view, basically tracking it from 2021 right through to 2033. And right off the bat, the growth figures are pretty striking. So get this. Global revenue was about $206 million back in 2021, expected to hit, what, $287.9 million by 2025. And then it's projected to climb all the way to nearly $560 million. That's $559.458 million to be precise by 2033. That works out to a really robust compound annual growth rate, a CAGR of 8.659% over that whole period. But why? I mean, what's behind this kind of growth for tech most people haven't even heard of?
Yeah, what's fascinating here is exactly that invisible part you mentioned. When we talk about an infrared light angle sensor, we're talking about a device that measures angles, like position or tilt, using infrared light. And the key thing, it does it with no physical contact.
Ah, okay. Non-contact. That sounds important.
It really is. It's a game changer in many fields because, well, no contact means potentially higher speeds, much better durability, less wear and tear compared to, say, older mechanical sensors.
Yeah, makes sense.
So it sounds niche, but this technology is actually fundamental. Think high-precision industrial automation, advanced consumer electronics, even critical safety systems in cars. They're kind of the unsung heroes, enabling all the precision and reliability we just, take for granted most days.
That non-contact point really does stand out. I can see why industries would increasingly lean on them. But if we dig a bit deeper, beyond just that inherent advantage, what are the bigger trends or like specific tech shifts pushing this market forward, especially in some of those really high growth regions?
Yeah, it's really convergence of a few major things happening. Firstly, you've got the whole push into Industry 4.0, right? Advanced manufacturing.
Hmm.
It demands levels of precision, real-time data that, frankly, older sensors often just can't deliver.
Like robots on an assembly line.
Exactly. Think collaborative robots, complex machinery.
Right.
Every tiny angle, every micro degree of movement needs to be spot on. Infrared sensors can deliver that. Secondly, miniaturization. Everything's getting smaller, especially in consumer electronics.
Right.
So AR/VR headsets, fancy camera stabilization in your phone, they all need compact, super accurate angle measurement.
Hmm.
And thirdly, the automotive sector. Big one. Things like active suspension, steer-by-wire systems, they rely heavily on these sensors for performance, yes, but also for safety.
Safety, yeah. Can't afford errors there.
Precisely. Even a tiny error in steering angle measurement, for instance, could have huge consequences. So it's not just selling more sensors, it's that these new, really demanding applications are becoming mainstream.
Okay, so it's less a rising tide lifting all boats and more a shift towards applications that genuinely need this specific kind of contactless precision. That said, are there any roadblocks, any bottlenecks, or maybe competitive pressures within the specific sensor market that might, slow things down a bit? Or is it pretty much clear sailing given these drivers?
Well, the outlook is strong, definitely. But it's not entirely without its complexities, I'd say. It's a competitive space. You've got established players, sure, but also new companies jumping in, all trying to innovate.
Innovate how? Like, what are they competing on?
Things like sensor resolution, how fine an angle they can detect, operating temperature ranges, making them work in tougher environments, and, of course, cost effectiveness, always cost. And miniaturization, while it drives demand, also brings manufacturing challenges. Making things tiny and reliable isn't easy.
True.
Plus, while non-contact is usually a big plus, there might still be some very specific situations, maybe extreme environments or super low-cost needs, where a more robust traditional mechanical sensor is still the go-to. So
Yeah.
it's dynamic. Continuous innovation is definitely key if you want to stay ahead and keep growing market share.
That's a great point about the competition and the need to keep pushing the tech forward. So, looking ahead then, what does the crystal ball say for these sensors? Where do you see the most, I don't know, significant new applications or maybe breakthroughs popping up by, say, 2033?
If we connect this to the bigger picture, the trajectory suggests they'll become even more, well, everywhere, more integrated. Beyond the stuff we've talked about, I could see perhaps greater use in smart city infrastructure, maybe for dynamic traffic flow management, things like that,
Oh, interesting.
or in next-gen medical devices. Precision and non-invasiveness are absolutely critical there. We might also see them playing a bigger role in environmental monitoring, maybe on drones, measuring subtle shifts, or perhaps in advanced human-machine interfaces,
Yeah.
like really accurate gesture recognition.
Just the recognition, right?
Yeah. Basically, the ongoing demand for smarter, more autonomous systems everywhere means the need for incredibly precise, reliable angle data isn't going away. It's only going to grow.
So, what does this all mean? Let's try and wrap this up. We've just journeyed through the pretty fascinating world of the infrared light angle sensor market. And it's clearly a remarkable growth story, right? Poised to more than double its 2021 revenue by 2033, hitting almost $560 million a year. That's supported by that solid global CAGR, 8.659%. And we saw how certain regions are really powering ahead, like Asia Pacific with that impressive 9.7% plus CAGR, and India leading the pack at over 10.8%. So it's clear this isn't just, numbers going up. It's really fueled by this increasing need for precise infrared-based angle tech across key sectors. The phone in your pocket, the car you drive, the factories making everything.
Yeah, and if we connect this to the bigger picture, like you said, the widespread, even if often unseen use of these precise angle sensors points to this broader, really undeniable trend. It's all about more automation, more sophisticated sensing in this increasingly connected world we live in. It makes you consider, doesn't it? How might this growing reliance on such specialized, super accurate sensors shape, future product design, safety rules? Overall efficiency in these key industries, it's fundamentally about building smarter, more precise, more reliable systems all around us.
Which raises an important question, maybe for you listening right now. Armed with this knowledge, you might actually start noticing the subtle presence, or at least the impact, of these kinds of invisible technologies like infrared light angle sensors in places you didn't expect in your daily life. It definitely prompts, I think, a deeper appreciation for the incredible precision that sits behind so many modern innovations we often just take for granted. Welcome to the deep dive. Today we're diving into a technology that's, well, quietly reshaping our world. Infrared light angle sensors.
Right.
These aren't just any sensors. They're pretty remarkable because they work by emitting infrared light and then measuring really precisely how that light reflects or gets absorbed to figure out an object's exact angle or position.
And all without any physical contact. That's the key part.
Exactly, no touching. We're talking about an innovation that's, redefining motion detection, smart automation, intelligent sensing, really across industries.
Yeah, it's quite broad.
Whether you're picturing, say, industrial robots or maybe cutting-edge automotive systems, even the latest wearable gadgets, these sensors are becoming, well, absolutely essential for next-gen tech.
They really are fundamental now.
Okay, let's unpack this.
Yeah, our goal today is really to get into this fascinating and fast-evolving market. We'll break down the key drivers, what's
Right.
pushing it forward, and also the restraints, what's holding it back a bit,
Yeah.
and the trend shaping where it's all headed.
So think of this deep dive as your shortcut to being, well, genuinely well-informed about a crucial technology.
Absolutely, something that's quietly powering so much of our modern world.
So let's kick things off by looking at why these sensors are booming right now. I mean, what's the biggest catalyst we're seeing?
Well, without a doubt, it's the surging demand for industrial automation and robotics. It's a huge one.
Okay.
These sensors, they allow for incredibly high precision angle and position detection. That makes them pretty much indispensable in things like robotic arms, automated machinery.
Right. Precision is key there.
Exactly. As manufacturing facilities, all over the world embrace smart automation for better efficiency, better precision, the reliance on this kind of infrared angle sensing tech has just grown steadily.
That makes perfect sense for factories. So from assembly lines to automated logistics, these sensors are like truly at the core of modern industrial innovation.
They really are.
But it's not just heavy industry, is it? I mean, where else are we seeing a big impact?
Oh, absolutely not. The automotive sector plays a crucial role too.
Ah, cars, right?
Yeah, with the rapid expansion of advanced driver assistance systems, ADS,
Mhm.
infrared light angle sensors are being used for things like steering angle feedback, even adaptive headlight control.
Okay, headlights too. Interesting.
Yeah, and what's critical here is the reliability. They offer these non-contact angle measurements, even in really difficult environmental conditions.
Which must be vital for safety.
Absolutely vital, yes,
Yeah.
for maintaining safety and performance in these intelligent automotive systems.
That's a huge leap for safety, yeah, and efficiency on the road. But okay, this isn't just about factories or cars. It feels like it's transforming how we interact with our everyday devices too,
Oh, definitely.
like gesture control in smart TVs or navigation in VR. What's truly revolutionary here isn't just detecting the angle, maybe, but how these really compact, low power sensors are enabling a more intuitive, almost invisible interface between us and our tech.
That's a great way to put it. And what's fascinating here is how perfectly suited they are for consumer
Right.
electronics. Their compact size, their energy efficiency, and their ability to provide smooth, sort of non-intrusive control. It just makes them ideal for powering these really immersive user experiences. Think wearables, remote controls, headsets.
They're probably in more things than we
Oh,
realize.
absolutely. You're likely interacting with them, maybe more than you think, perhaps in your gaming console or even augmented reality devices.
Okay, so we've explored the immense potential, but like, any cutting edge tech, these sensors, they aren't without their complexities, are they? What are some of the key limitations we should be aware of?
That's a really critical point.
Hmm.
One major challenge for these infrared light angle sensors is definitely their sensitivity to ambient light and interference.
Ah, okay. Like sunlight,
Exactly. Since infrared sensors operate within the same spectrum as, heat and sunlight, they can easily be disrupted by external IR sources.
which makes them less reliable outdoors, maybe.
Precisely. Less reliable in outdoor or uncontrolled lighting environments. And that can significantly limit their effectiveness in certain industrial and automotive applications where, consistency is just paramount.
That sounds like a pretty fundamental challenge. Hmm. And what about the cost? Are these like a premium technology or are they getting more accessible?
Well, compared to more traditional sensing tech like potentiometers or maybe resistive sensors, they do have a relatively high cost.
Okay. Why is that?
It basically comes down to the need for specialized optics, calibration, and quite sophisticated digital signal processing.
Right. More complex components.
Yeah, so it often requires a higher upfront investment, and that can make them, less appealing in cost-sensitive applications or maybe entry-level products where the budget is really the primary concern.
So for some uses, that precision and the non-contact aspect, they justify the price. But for others, it's still a bit of a hurdle.
That's right.
What about their actual operational limits? Are there environments where they just struggle to perform well?
Yes, there's also the issue of limited range and material interference.
Material interference, how so?
Well, these sensors can really struggle when you're trying to measure angles over long distances, or maybe through materials that absorb or scatter the IR signals.
Oh, okay.
So this raises an important question, right? How reliable are they in really diverse environments? Things like low reflectivity surfaces, maybe curved shapes, or complex multi-surface environments. These can definitely distort the accuracy.
And that hinders adoption in some tricky use cases.
Exactly, where environmental factors aren't uniform or predictable.
Okay. Despite those hurdles, though, the horizon for this tech still looks incredibly promising. Let's maybe shift focus to some of the emerging trends shaping the future, starting with miniaturization. Seems like everything's getting smaller.
It really is. It's a growing movement across the entire electronics industry, and infrared angle sensors are definitely no exception.
So smaller sensors.
Yeah, as electronic devices keep shrinking, manufacturers are developing increasingly compact sensors, ones that fit easily into, say, portable tools, smart glasses, fitness trackers,
Schlimmer glasses, wow.
and the advances in MEMS technology, microelectromechanical systems, that's really enabling these sensors to deliver robust performance while consuming minimal power.
Which is essential for anything battery powered.
Absolutely essential, yeah.
Mm.
For battery-operated devices, low power consumption is key.
That's a huge step forward for just widespread adoption. And what about beyond consumer gadgets? Are we seeing these sensors move into completely new sectors?
We absolutely are. Another really powerful trend is their adoption in medical and healthcare applications.
Healthcare. How are they used there?
We're seeing them used in everything from surgical robots,
Surgical robots, okay.
yeah, where they track motion with exceptional accuracy for, really delicate procedures,
Yeah.
all the way to physical therapy devices.
Huh. And why are they good for that?
Well, their non-contact nature is a huge benefit here. It makes them ideal for maintaining hygiene and patient safety.
Ah, right. No touching, less contamination risk.
Exactly, which aligns perfectly with the strict regulations you find in medical environments.
Surgical robots, that's a level of precision that, yeah, feels almost sci-fi.
Yeah.
Okay, finally, what about the marriage of these infrared sensors with other cutting-edge tech? Is AI playing a role here?
Oh, definitely. AI-enabled sensor fusion. That's perhaps one of the most exciting areas of progress right now.
Sensor fusion, what does that mean exactly?
It's where you combine infrared sensors with other devices like accelerometers, gyroscopes, maybe cameras, and then you integrate all of this data into AI-based platforms.
Okay, so combining sensor inputs.
Right. And if we connect this to the bigger picture, it means these technologies are just getting smarter, faster, and more responsive.
So what can you do with that?
Well, this fusion is creating things like advanced gesture recognition systems,
Yeah.
posture correction tools, even autonomous navigation systems for robots or vehicles.
Right.
It's largely thanks to these innovations in infrared angle sensing combined with AI that our world is becoming more, intuitive and automated.
So, okay, to kind of sum it all up then, the infrared light angle sensor market is clearly thriving. It's playing a critical role in automation, mobility, smart devices, even healthcare now.
Definitely booming.
And while there are certainly some technical hurdles and cost issues to overcome, the advancements we're seeing in sensor design, AI integration, miniaturization, it seems like they're really setting the stage for substantial growth and innovation ahead.
Absolutely. The trajectory looks very strong. And maybe something for you, the listener, to think about.
Yeah.
As you interact with your devices day to day or drive your car or even just consider the future of medicine,
Yeah.
maybe ponder how deeply this invisible light technology is already shaping the world around you and, what new possibilities its ongoing refinement might unlock next.